Cool. We are now recording.
So,
Cool. Well, given that we're almost 10 till, or 10 after, I should say, wanted to kick things off here. Thanks everybody for joining us here on a Tuesday evening, especially when we haven't had a meetup here in a couple months. I think maybe our last meetup was April or March. And, things have been somewhat sporadic as we still wait for a normal life to resume again and for things to open back up. But I know there has been some conversation around doing in-person meetups once again. Not sure, can't make any commitments or promises on that front yet, but it's something that we're still evaluating as we go. But of course, would love to see all of you again soon. Just kind of getting into some things. Yeah, I hope everyone's doing well during the pandemic. Of course, wanted to take a moment to shout out our sponsors for the meetup. As always, we get tremendous support from Zoom, who's given us this license to basically hold these like unlimited duration meetings. And that's enabled us to continue running these meetups remotely. So huge thanks to them. And then as always, Turing and Salt, who have helped us out and sponsored the meetup in a variety of ways. Turing, notably being the physical location in which we hold our in-person meetups, which again, hope to see you guys at Turing here soon. But moving forward, in addition to our sponsors, we're also supported by our Open Collective members, those who have decided to help us out with our expenses on Open Collective. That's been a really good platform for us and just managing those expenses transparently, even though we really haven't had any expenses in the last year, to be honest, but we still very much appreciate the support of everyone who has donated to us there. So thank you. In terms of who's hiring, if you have hiring details or are interested in job opportunities, feel free to post in the chat. Otherwise, you can also feel free to post on our events page itself. That's probably going to be the best place, given that we don't have the typical whiteboard to go to. So feel free in the chat or, like I said, on the event page. And same goes for announcements. I know we just had some discussion around in-person conferences that are coming back here in the summer and fall. And I believe there's, a few URLs that we may throw in the chat there. Same goes for if you have any other announcements related to, web development, tech news, anything like that you wanted to shout out, feel free to post that in the chat, of course. As always, we usually give a shout out to our organizing team. It's been kind of a weird year for us, of course, and we're always looking for more help, especially as we look back to go into in-person meetups. I think this will especially be a point for us. But if you are interested in getting involved with the meetup, we are absolutely interested in having you. I think it's a great opportunity, especially for devs who are, both established, but also newer in their careers. If you're wanting to have an impact on the community at large, this is a great way to do that. And we would love to, get you involved with the team any way we can. So if volunteering with a meetup interests you, please feel free to reach out to myself, Jeff, Will. We're all on the call here, or just message us on Meetup. There are many ways to find us. Our Twitter as well, you can DM the Twitter account, and we could certainly point you in the right direction there in terms of how you could help us out as a meetup. We would really appreciate that. So with that, I want to introduce our speaker. We're very, very grateful to have Adam to have stepped up in the last, I feel like I've been talking to you for 3 or 4 months now, organizing this talk and, trying to find a date. And I'm glad we finally settled on this one. So very, very grateful to have Adam speak to us tonight about front-end architecture. So with that, Adam, I think we'll give you a chance here to set up your screen. Let me stop the share so you can, I assume you have slides, I guess. I didn't ask, but yeah, I'll let you share your screen and we'll let you take it away.
Awesome. And to echo what you said, if anybody does want to volunteer, that is something which I did at a previous meetup in Boston when I lived there. And it's one of the best networking opportunities too. Like you meet so many people. So if you are either looking for a career or like hiring or anything like that, it is also great opportunities to get involved, and you just end up meeting lots of awesome folks that way. So highly recommend it. That said, let me jump 2 slides. And Zoom. Okay, right. This is different. One moment. I'm gonna go ahead and
No
share
pressure.
my desktop one. Oh, okay. Yep. Done only on one monitor right now. So just share the one that's up.
Perfect.
All right. So, and let's see. So I may or may not have a couple tabs open right now, and let's get back over to the one that is actually active. And okay, so quick background about myself. So I've been a developer / software engineer for a number of years now. And let's see, can this be minimized? Okay. And so, well, all the Zoom bars are in front of the screen that's being shared now. So one moment here while I pull this all out of the way and figure out how to make this disappear.
If you maximize the screen, or is it still displaying it for you?
Yeah, I've got, so I am trying to go for having the next slide up here on the right. And so if I maximize the screen, then I can't see those anymore. So that's the downside of being only on a laptop right now.
Sure.
So, okay, good enough. And if there's a problem, I can just drag it around. So, all right. So background about myself. So currently lead engineer at Switchfly. Originally background in counseling psych, and then went on for another degree in computer science, and really enjoy blending the two. Right now doing that as a lead engineer and leading a team here at Switchfly. So we are working in travel, and we are architecting a greenfield platform right now, which is so like starting from scratch. And so this whole presentation comes out of like my looking into, well, how do you enable fast change, fast error-free change as a team of developers, and how do you move fast as a team? So on to, does somebody have music on?
I'm hearing that as well. I'm not sure where that's coming from.
Okay. Well, we have a soundtrack.
Yeah, we do. I'm just going, awesome. I'm just mass muting people. So hopefully that works.
Awesome. That's helpful. Thank you.
Yep.
Sweet. So next is, let me just jump in then and get the slide key back. All right, so key points. So quick intro, and then jumping into graph theory, and just a little bit of a refresh on that. And then looking at some of the evolution of architecture, some heuristics that I picked up, and then also some current tools, including like Redux and Graphql, comparing those and looking at potential improvements on their architectures. In light of newer things like recoil and other technologies. So that said, so the first one is like all these different technologies. So we have React, we have Vue, we have Angular, we have Ember, which is, and then we have the satisfaction over time of all these different technologies, and the new ones that have sprung up recently, Svelte amongst those. And why? Like, why have these? Why are some tanking? Why are some taking off? And what are the common patterns in there? And so, trying to understand that, looked at just some of the ways of thinking about the relationships between things in the code with these different types of technologies, and what types of in graph theory, you have nodes and edges. So what types of nodes and edges exist in these different frameworks that make some more pleasant to use than others? And so, so if you're unfamiliar with graph theory, there's a link down here at the bottom, which is where these articles or these pictures come from. And this is, it's basically just you have concepts and you have relationships between those concepts. And so each of these nodes being a concept, and then each of these edges being a relationship between those things. And you can see here there's directed edges, where it's an edge from one thing that to another that goes in a specific direction. So like a dependency between one file and another would be that type of edge. And then in this undirected edge is another type, which you can see that as either as an edge with no direction or an edge with two directions. So that's the really quick jump back on graph theory there. And if you are unfamiliar with graph theory, again, check out that link at the bottom. It's a really great introduction. And so, all right, so looking at nodes and edges in this case. A number of years ago, well, we started with jQuery. jQuery was just like a whole big ball of lines and edges between those. And we got to MVC to try to organize things. So early backbone, Angular before 1.6. And there's also variants like MVVM. So Knockout.js was one of those and others. But basically, you had a number of lines between the different components. And you had bidirectional lines. And then the evolution of that was Angular greater than 1.6. And then when React really started taking off, you started getting this component architecture where instead of having the separation of concerns around models and views and controllers, you really blend all three of those things in your components. And components then handle all the relationships between those things as well. It's a much simpler setup. However, it forces everything into a hierarchy. And so sharing data between things, there's not a clear way to do that there. So we started to get into to solve some of the problems with both the hierarchy and with some of the model-to-model interaction. Started to get into the Flux pattern, which the original video was posted, I think, at the end of 2014. And that was, all right, well, how do we get from this like mini direction data flow in MVC to the unidirectional data flow in Flux? And then have all those interactions be unidirectional lines, so sort of, or directed edges, as you would call them in graph theory. And from those, we then simplified further. And so Dan Abramov came up with Redux, him and Andrew Clark, and then created this pattern here. So it's like a single reducer, single object, and then it all goes through this, through a unidirectional data flow here, and they incorporated the node pipeline concepts, or like express pipeline of middleware. And then, so I'm sure most people in the audience are familiar with that one. And there were also some others in there, like MobX, which had a more atomic state, which you could have dependencies between things that would automatically be resolved. So that is a little bit more like Recoil is now. And however, there was something after the advent of MobX and Redux, where then Graphql came on. So that's an API contract as well as the clients that handle that. So you have Apollo, Urkel, Relay. And that has yet a different kind of flow, where instead of having a unidirectional pipeline like this, all the current clients, as far as I've seen, have go back to a multi-directional pipeline. And that is, GraphQL is kind of weird because the spec doesn't really distinguish between front end and back end well. It provides sort of the contract between them, but it doesn't specify how a client should be built or how a server should be built in that case. And so that leaves a lot open to interpretation. sort of, I don't know, there are a lot of concepts coupled in the spec which have come out in the different clients, and you see some of those, but the result is you end up with this pipeline architecture, and you end up with like bidirectional mutations. So mutations can return data. So they can both do, whereas in this case you do a command, it comes through, and then that comes back down and then filters through here in queries. Whereas in this case, a mutation is both a command and a query at the same time. So you get bidirectional data flow yet again. And so that has some pros and cons, but we'll dig further into that a little bit later. And so that's it for history. So at the same time, you'll be asking, wait, but are there really like less arrows? Like, are there fewer edges in this kind of model than there are in, say, a Redux model where you get the unidirectional data flow? And so there might not be less edges. However, the thing is that it's easier to reason about edges going in one direction, and you don't necessarily see the difference there, but where you really start to see it is when you go one level deeper. And so when you start getting down to the model to model relationships, you can have a whole bunch of interactions and requests and updates going back and forth between those components. And that yields also non-determinism, which then can make things very difficult to debug. So this picture here is directly from the original Flux video, and highly recommend that one. Really well done talk overall, well told stories and everything in that one too. So that is one of the problems they were trying to solve, is how do we deal with the non-determinism? How do we deal with all the bugs that are cropping up? Well, it turns out that going to a unidirectional data flow does help with those things more. And okay, so so that is one way we get both less arrows, we get less, so more deterministic. There are a few less arrows in this architecture than there would be in a multi-directional architecture. However, that is not the only scope. Like, this is data flow. There are other areas where that trend towards just less edges and simplification of the overall graphs has continued in other areas. So, for example, CSS. And we went from style sheets where you had the both sort of a mental model or a domain model, and that would be tied to selectors and attributes, which would be these huge style sheets, which would be cascade specificity. And as an example, we had one file at work, which was literally our buggiest file in the organization, was a CSS file with thousands of lines. But all those dependencies and all the ways that you had to map from that to the component graphs within the HTML end up causing just a lot of challenges to maintain, keeping track of all of that. And so the simplification was going from all these different trees here to then selector matching the component tree to just co-locating our attributes directly in our components as well. And another area, which for those of you who have been working with React since before the hooks days, was the advent of actually hooks was the improvement there. So if you look at the number of edges, and so when I talk about edges, I'm talking about structural edges in this case, where you have, for example, so class incrementer extends component. And so can everyone see this slide? All right. It's a little bit small on my screen, but my screen is also tiny.
It's a little small, but it's legible. Okay. If there's a way you could zoom in, great. But if not, I think it's legible.
Let's try it. Not, apparently no. So let me, I guess I'm sharing my scripts. So, well, that's a way to get around fast. Let's see if, I know there's some way to do, nope, okay, that's not gonna happen. Get back there. All right, so the first, so it's, if you think about like a structural edge, like this dot set state, you have an edge from an object, which is this, to a in this case, method, which is set state. And so this dot is that sort of saying, hey, there is an edge from this one thing to another. There's also an edge from this increment to the body of the function, which is the increment. And so if you think about an AST, which is an abstract syntax tree, it's what Babel would, like if you work with Babel, that's what you would, the interim representation of your JavaScript would be an abstract syntax tree. So the tree of this, of a class component is nearly double the number of edges as a hooks component that has exactly the same behavior. And so I have some links here with the both code, AST generation, how you can generate that, and then actually counting the edges. This was the function I used to do that. And so what that means, so this is important because when you are changing your code, the number of edges you have to change to create a feature is how fast you can move. And so the more edges you have to change, the longer it's going to take you to make new features. And so by cutting the number of edges in half for similar features, you are nearly doubling the possible velocity there. Now, there are some more fixed costs, like your time to think through, state, how long is this, like what order of operations, like what order does this effect happen in, all those kinds of things. But from the actual perspective of changing the code, it is going to be faster when you have fewer edges. And you see that in other frameworks. So like what has made Vue and Svelte example, for example, better to work with. So if you go on the Svelte site, they talk about, they do comparisons of number of characters. However, I don't believe that number of characters is actually that important, because the number of characters is, I mean, you have autocomplete, sure. I mean, it takes to type more. However, the number of characters is not as brittle as if you have like one object that is coupled to another object. It is easier to work with the abstract syntax tree or the structural edges between things, for example, between input and type number, or between input and this thing, paragraph and these variables. Changing those things is what's going to take more time. And those do have slightly better number of edges in this example. Now, this example of Svelte, I didn't even include the React example because they compare a number of characters, but then they sort of pad the other frameworks examples. So you can write Vue more succinct than this. And like, do you really need a function that returns, has a return statement and returns this object, or can you just use an arrow function? So yeah, take that with a grain of salt. This would also get much shorter if you use the same concepts and you use the shortest JS syntax you can. And the same would apply for React. But so that said, that trend in these different libraries seems to be what is fueling. If we look back up at the top frameworks here, it's going to be React, Vue, and Svelte, and all three of them have some of the lowest, some of the shortest syntax for being able to express things. And so that seems to be what is keeping things at the top of the heap so far. We'll see with Svelte and Vue if they decrease over time, like Ember has, but that seems to be a common trend. So less structural edges seems to be valuable. And that is also true. So structural edges are one type of edge. There are also names, and names are tricky. So that's where we get into semiotics. So semiotics is a combination of syntax, which is like the meaning, or sorry, semantics, which is the meaning of the words and combinations of words, as well as like syntax is how we combine them and the rules for that. And then there are another aspect of that called pragmatics, which is rules in context. Like you have different rules for using words at work versus using words maybe on a different project that does not work or something like that. However, the tricky thing is that you are taking these concepts, which are essentially a graph of concepts in your head, and then you're flattening them to these things. And so then you're taking all of these and you have to decide, all right, well, let's come up with all these edges between the words and what order they're going to be in. And the more words you add, the more complex the graph gets of the words. And that really causes problems for communicating. So when you are trying to communicate to another person, that you have to take all of those, all the concepts in your head, you have to flatten them into some sort of representation. And then the other people that you interact with also have to unpack that in their head. And you hope that they take that flattened version of it and unpack it into the same concepts. So the less words you can use is better, because often what happens is the way we think things, others are going to interpret concepts. The more that we end up having this sort of jumble in the middle, where the concepts we want to communicate to others don't really work, and so then you have to go back and ask questions. What does this word mean, and like what does this function mean? So going with fewer words is something that was also another benefit to that decreases character count and also is makes things easier to learn. And I don't know if you guys have looked at Ember recently, but the number of words in the Ember API, there's a good reason Ember is down at like 27% as far as interest in using. And let's see, so take a quick drink. All right, so a few of the rules, I'm not going to go into these very much, but as I was looking at the different frameworks and some of the different aspects of them, and thinking about what other graphs I was working with, these are some of the heuristics I came up with for myself to think about, all right, what structures are better? So an easier one is a set versus line path. Like these are better to use. So a set is an unordered list of things. And so if you are working with a set, you don't have to worry about order. You just grab what you need, and you really just, there's no other dependencies to worry about. Whereas in a line, you have order dependencies, where it is a straight line. You don't have to worry about like any other branching off of that, but you can't just grab something out of it because it depends on being before one thing and after another. A path is like a line, but then there are branches off of it. So you still have to make decisions about what to select in there. So if you have an object with multiple properties, that's actually a path where you have to select which properties you're going for. And so that's one example. Synchronous edges are easier to think about than async edges. Like we have a hard time processing things over time. Near edges is better than far edges. Yeah. So there are a few lessons on there, but I'm not going to go into those right now. Just including them in the slideshow as a reference if anybody wants to come back. So what do we care about? Like, what are the important parts? And so there are a few types of graphs that are the most, that are sort of distilled out of those points. And so we have the first, these two are flow states. So if you have a async edge versus a synchronous edge. So if you are just making a function call, then that is like you have a function that does, add one thing together. Actually, let's go into some examples of that instead of just talking through it now. So here is, let's look at this with directories. So in this case, we have, for example, components, we have stories, and we have our data. And so then our component might have a person and person.js, and then stories might have person stories, and then we might have the same concept in our data, and then maybe actions, selectors, reducers, etc. Now our component then imports some of the stuff from our data here, and then our stories then may import our component. So in each of these cases, there are edges between things. And so we have a concept, which is like, so components to person in the directory structure is a structural edge, which is the sort of bluish edge. And I hope that's visible enough. And then the, can I hide this? Okay, well. Okay. Can everybody see these lines decently, even if they're small? Like, are they clear enough? I developed this on a screen about twice the size of the screen that I'm currently presenting on, so I just want to make sure that everyone can see.
I think the large curved ones are easy to see, but for sure the lines on the left are a little bit tougher, so
Okay,
may require some more clarification.
okay. Let me try doing a
Are you
full.
trying to minimize your bookmarks?
Yeah, basically get rid of the bookmarks bar, or I think I'm just going to get rid of the presenter view and I'll just wing it.
You can actually minimize Command Shift B, takes away the bookmark bar there.
Oh,
I'm not sure.
I,
Yeah.
I think like the big part of the challenge that's going to happen. So right now vertical is not the limit here. So it's going to be widthwise.
Oh, sure.
Let me go ahead and just, oh, I know there's oops. So Command Shift F, is that full screen? Yeah, okay, there we go. And awesome. So here then we have, so a little bit bigger. And so we have so each of these things are both a semiotic edge and a structural edge. So we have a structure, like a directory goes down to the second directory, which then has inside that a person.js file. And so you can't change the directory structure without, like the relationship between these things like would break. Like if you move person around, you have other dependencies that are going to break. And then the semiotic edge, though, is something where components relates to person, is within here and whatnot. So there are both of those kinds of edges in that case. And here you do have a relationship from person to test. So this test it tests person, whereas this is stories related to person and so on and so forth. And so what does that look like? For the number of edges, just trying to count this is, as I went through, I'm like, okay, well, if you look at actions, and if you have person.js importing actions here, you basically have to go up from actions to person to data, up to components, down to person, and then back to person.js. And so the deeper your structures get like that, the harder it is to change things. And so limiting those structural edges can be beneficial. And so we've started to look at that with our front-end directory structure. So this is what we essentially have right now. And I've gotten to single file components now for our React, for all our React components. And so that has also combined with stories. And so for our components, we just have this one file. I think Storybook right now does not have, I think it depends on having the story's name in the file. So I'm not sure, I haven't figured out how to change that yet, but I haven't worked that hard on it. So eventually I'd like to get it to person. But so for now, have that semiotic link there, as well as just edges, the only edges from component to person. So here, where we are going from this component to the data person.js, we are, instead of 5, for those jumps, we've gotten it down to 3. But going to single file components instead of having all of these things in separate files, and that is also enabled by sub-file like named exports and things like that. And that's gotten us down. So like from 36 structural edges to 5 structural edges is a lot faster to change things and to find things. So it does require some care with the name of exports, but that is something that can very much be done. And so it's much easier to navigate this system for new engineers than it is for navigating this kind of system. And then getting it a little bit smaller is what I would eventually like to do. And I was really considering whether not to go this far, but we can. So that is eliminating the directories. And so if you eliminate the entire directories themselves, you can get even fewer edges. It does require a little bit of different globs in your build file or in your build setup, and there are probably going to be some tool limitations. And so I'm not sure I can get this far. However, This makes for no directory edges. So it's very quick to make changes in your structure when you have no directories that you have to worry about and like move things around in. So you can change faster. It does like require a different mentality as far as finding the like search behavior. So instead of drilling through a bunch of files, which does take time, you would just use search. So like Command Shift, whatever that is in VS Code. I have alternate keyboard shortcuts, but one of those file opening commands to be able to just search all of your files currently. And so that's one direction we're going. Let's look at some examples that are also, that are code examples though. So that's directories, let's look at code. So anybody want to take a stab at how many edges there are of each type in the first example here, just in person name? Any brave souls out there? And I promise I won't bite. Come on, you know you want to. Someone can guess this. There's only one edge. So you have a 1 in 5 chance of being right.
We've got a couple guesses in
Oh,
the chat.
oh, I can't see the chat. Right.
Yeah.
Let me see the. How can I view that here? And. Okay. Anybody know offhand how to view the.
Look on chat on the bottom left.
Ah, okay, there we go. Ah, got it. Thank you. All right. And can anybody see the chat window, or is Zoom hiding that?
No, we cannot see it on your screen.
Okay, awesome. Cool. Okay, so in the identifier, 2 and 1. And so over 9,000. Well, so yes, there is one. That is absolutely the correct answer there. And let me see if not. Okay, so so there is one in this one, and that is one semiotic edge. There is, how about in the second one? So in person name here, and I'll just go ahead and, oh shoot. And all right, guess I can't edit it while in presentation mode. So, yeah, any guesses on the second one? So looks like Shady got the first one. And 2, that is getting, yeah, which 2?
I guess from person and to name, right?
Which, oh yes, from person and to name. And so which 2 types?
Semiotic, I guess.
Mm-hmm. Yep. So from person to name would be a semiotic edge. That's the same edge that's in this one. And what's the other one?
Structural.
Yep, exactly. So in this case, you have an object, which is a person, then you have a structure that you are referring to this property of that object. So this is both a semiotic edge, so from person to name, and it is a structural edge. So I'm not going to go through the rest of these. I included them for as examples, but so here is the 2 we just looked at. So the one on person to name is one semiotic edge, and then person to name is both a structural edge and a semiotic edge. And so when we looked at those directory structure examples, when I talk about flattening the tree so that you actually just use, like, you go from components to person stories to components person, like that, you are changing it from a structural and a semiotic edge to just a semiotic edge. And so that's what makes it faster. You're removing an entire dependency graph from that. And the structural one is, if you take anything from this talk, the quick win is remove structural edges. They are going to they slow you down. And like sometimes you end up with longer names, but longer names are faster to change still than shorter names. Okay, so yeah, some extra examples in there. This one is like, you can see very quickly, it doesn't take much code to start having a whole lot of edges in these examples here. And so the promise you get, for example, a async edge, an async or flow sync, flow async, and a control edge, because you go to then, which is one of the options. You could also go to catch. And so this one doesn't actually have any semiotic edges in it, but it does have one control edge for the if statement. So, and all right, so, oh, it's not clicked in the right window. So data flow, all right. This is where we get into the frameworks more deeply. So Redux. And this part this is what I'm actively doing for work right now. And so it is figuring out, all right, what is the actual data flow between these frameworks? And given the way that their structures are, which are we going to be able to change the fastest? And there are some aspects to them that this came from an earlier presentation. So whoops. So there are, let's see, I think I got all of them, but yeah. So directory trees, semiotic network, action creators, which looks like a duplicate. I think that was meant to be reducers. Yeah, so there are a number of pieces of this that are things which are composed together ultimately into our components, as well as like what are the data flows and the types of edges between all of the things that happen in a middleware pipeline. And then once we get into the Redux store itself, we've got control flow edges, as well as structural edges, as well as semiotic edges. And there's a lot going on there. Those, for the most part, are unavoidable, but yeah, there are. So starting to break this down is what is one of the parts that I'm going through. The thing about Redux, and it is simple. Reducers are a good concept. There's even a tweet from Andrew Clark saying, yes, reducers are like the one good concept of Redux. So all the middleware, there's an article called Redux is Half a Pattern, which is actually really good one to read. And that one also talks about like, it's a little bit chaotic in terms of like, how does middleware work? How does like store enhancers work? How does like all of these things like sagas and keeping track of all of that is a little bit difficult to follow, and there's some indirection in there, as well as like you end up having to filter on the names of the events at each stage in this. So you get logic edges in there at each stage, and then you get an entire, this whole part of the tree here from the root state down to the nodes within that root state are like, that is an edge which doesn't have to exist in more direct, like in things like recoil, where you are changing the state of atoms directly. And so there are some edges that can be removed there to make that a little bit simpler and also more performant, because every time you make any change, it has to do a copy of the entire state. So that has been some of the challenge of this like single immutable object, and then also a single pipeline. So that I think is one thing that's going to be changing. I'm in the middle of doing the GraphQL part. So GraphQL is interesting in that it's gone back to a bidirectional pipeline, and so bidirectional starts to get problematic. And so the same problems that we encountered in MVC with non-determinism, I'm still getting into how they prevent the problems of MVC with GraphQL, like with all the asynchronous edges, or like with the bidirectional edges, like in mutations. How do you prevent that difficulty following things that comes with bidirectional async edges? Like it is very difficult to mentally follow those things, and so like how do they overcome that? Well, and I haven't found an answer to that yet. But as soon as I do, I'll include it in this slide as well. And so maybe a potential future talk, but we'll see how that goes. And so the challenge so we have those bidirectional edges, and those are going to have oftentimes some control edges in there as well, because you also have to have like when you get a response back, it's in different states, and so you end up having the if state is loading, if state is error, etc. Within these structures, within your components. And how do we remove that? And how do we like deal with a lot of these batching and catching? So in a unidirectional pipeline, things go through once and they go through in the direction, like in a single direction. But when you get a batching and caching and all of these different things, one, you have the same problem as you do with the Redux pipeline, but you get it twice because all your operations have to go through the pipeline. And this pipeline is true for Apollo, and it's true for with Apollo links and then Urkel extensions, or I think it's extensions, where it has a bidirectional pipeline in both cases. So it goes the outflow, and any of these can modify that flow, and they can then make that flow async or sync. And then they also have the inflow coming back through from whatever the output path, or whatever whether they hit resolvers, whether they go to an API, whatever they do, any of these paths can stop anywhere in between. It can submit it can submit more requests. And that gets difficult to follow from a debugging and from a debugging perspective, where you're trying to figure out what is the flow when there are so many possible permutations of paths that things can take, and conditional logic on each step of, all right, well, how do we, like, is this going to pass through the filter, or like, is this going to be caught by this, like, is this going to be cached or not? And then you have to have configurations around that. So there are it adds a lot of complexity to have this sort of bidirectional pipeline that can be async or sync. And so it's a lot of responsibilities, and separating those responsibilities is something I think we'll get to. And so that brings me to what I think we're heading towards in the future. And so, so with recoil, you set directly to atoms, and so as part of that, you essentially have a pipe to every atom. And so I think that's going to be the direction we head, which is, so multiple composable pipelines. So in the case, like with Redux and with any of the GraphQL clients, they're not fast enough to do animations well. Because they have to pass through all those pipelines, and those pipelines have to do basically pass things along, even though they might not need to operate on them. Things like animations do not perform well in those contexts. So I think that getting something that allows for some of the strengths of both GraphQL and Redux is one of the ways that we'll go, but with separate pipelines so that you can have those things when you need them, and you don't need to pass the operations through pipes that do not need those operations performed. And go straight directly to the parts of the graph that are that you want to operate on without all the other parts of the graph, so you don't have the performance issues of, for example, like the Redux full state copy on every operation. And then returning to the unidirectional flow, because of the simplicity in debugging, as well as just thinking through problems when there is a unidirectional data flow, it becomes just faster to reason about the flow of the data through the system. And then if you have bidirectional, and especially if you have bidirectional that is asynchronous as well. There are just fewer edges and fewer possibilities in a tree than there is in a network where you can go back and forth. So the number of possible paths and the number of possible edges is much greater in those paradigms. Also, more schema-derived code. So I don't know if you guys have, does anybody have experience with GraphQL code gen at this point? Like, I have not used it yet. However, as I have looked at it. So how have you found that GraphQL Cogen has done for your ability to move fast and to create new features compared to not having it? So whether that be Will or awesome. Beautiful was the answer there. So beautiful in terms of speed or ergonomics of how pleasant it is to use, or okay. And Jeff, did you mean beautiful in terms of, okay, yeah. Schema drives the gen. Nice. Yeah, I've seen it. I've seen it both ways. One where the queries themselves can generate essentially a client schema, but then also the other way I was thinking about it was essentially you can derive a lot of code in theory from just a schema like this. And so that's what I was hoping. And as I was considering whether to dive into that, I'm like, well, that makes a lot of sense. And so this type of person. Hasura Cloud for the server part. Okay. Yeah, I'm not as familiar with that, but yeah, for the GraphQL Cogen, the type and so given this type in a schema here, we can generate, for example, a query person's ID, query person's friend's ID. So let me talk about that a bit. So there's move the chat over. So one of the interesting things about schemas, and if you start to think about the semiotic edges and the structural edges, often when we submit queries, we are submitting a query that's a tree. So you submit a query with different properties, and maybe it looks like this person ID here with a name. So this is person, then you have an ID, then you have this name, and this is like 3 parts of a tree here. You have query, person, and name. And so you're submitting what is essentially a path in a tree. And because of those are structural edges as well. So, so with those, when you get back a query from that, you end up getting the same tree back that you've requested. Then you have to dig through that. And so then you have to do like result. So this ends up being like result.data.person.name. So you end up with 4 structural edges just to be able to parse a query like that. And so given the distinction between the semiotic edges and the structural edges, my suspicion is we will eventually start getting to the point where, or at least, so we'll eventually start getting to the point where we start using semiotic paths instead of structural paths because they are faster to change. And so instead of saying query person ID name like that, like literally query person ID, query person name. And so having semiotic paths that point exactly to the node in the graph that you need instead of having to dig through a tree to get it. And so that is one of the things that I think will be an evolution eventually in generated code, so that all of these would be generated for you based on whatever your schema is, and you just import the semiotic path that you need, and you will get back that exact type of information you're looking for. Then also separated responsibilities, and so that's related to the schema-derived code, is that there would also be so separated responsibilities, that's really like, instead of having results as error, result loading, all that kind of stuff, because we could just return the data would be the name, we would just say person name equals use person name ID and so on. The interesting thing about those paths to direct parts of the graph is it also enables another aspect, which is that if you can point to any two parts in a graph, then you are effectively working with sets or collections. There are about 6 cases of what you can be working with. And in those, any operation, like you can get to standardized operations. So any change between 2 sets of a node in a graph can be expressed in terms of 4 operations, like standard set operations. So instead of having to come up with a bunch of names for your operations, you can use intersection, union, add, and subtract or difference. And those 4 operations can effectively make any change you need to in the graph. And so I think we will be able to standardize more of the names, which should also reduce the number of decisions we need to make, so help us go faster, as well as increase onboarding speed and things like that. So that is one thing which I have prototyped a little bit and seen some benefit from, and it seems to be possible, especially when we can chain them. But that is probably one of the coolest things that I think will be coming up, is just not having to name our operations because they can all be expressed in the same way, given the shapes of the graphs that we're dealing with. So, and that is, I believe, oh, right. There's one challenge in having this kind of shape where you have a bunch of different trees. That's debugging. And right now in our Redux dev tools, we have you see things come along the pipeline in a specific order because we flatten them into a line of objects, into a string of objects and event objects. And the thing when you get a graph with multiple pipelines like that, and especially with separate nodes like you do in Recoil, is that you end up having to debug across a broader set of things. And so that is where like better tooling for debugging graphs. And so this would apply both in GraphQL clients as well as like in Redux. This example here is actually a time traveling example from a presentation that's almost like 3 or 4 years old that is an RxJS example, where it showed, given a number of observables, all the changes running through that graph and what it looked like over time. And so just like you are looking in Redux dev tools, you can see the information flowing through, you can see all the changes. So I have linked the talk down here. It's a really cool one to watch. It shows a lot of the things that Redux dev tools can do. You can see how that all works in a dependency graph. And so I think that, as well as what does that dependency graph look like as you watch data flow across the front and the back end, would be one of the things that we'll see over time as well, as we get more familiar with working with graphs and common data formats to log those. So all that said, happy architecting, and that's the end of the talk. So any questions? And if you have and I meant to say that at the beginning, which was, hey, if you have any questions, feel free to post them in the chat and I'll come back to them. We're at the end, hopefully. If you have any questions, I would be happy to answer them at this point.
And feel free, if you want to chime in,
Yeah.
via audio, you can do that. Or
Yeah.
if you just want to post them in the chat, that works too.
Yeah. Also, any experience with these tools as well, because like some of these, I'm picking up here. I've used some and done some prototyping with them. However, like if you've used things like GraphQL CodeGen, you probably have more experience with these kinds of things than I do. So you're also welcome to tell me like, oh, there's a better way to do this, or like whatever. So I definitely don't know everything, so I always love to learn.
You have totally, I can't speak for everyone, but you've totally inspired me to go back and learn more about graphs and nodes and edges and all of that, and really trying to analyze some of our front end structures. And yeah, this is not something that I often think about, especially while I'm working on a story, but I think it is so fascinating. And so, Yeah, I have many questions. I don't even know where to start, to be honest.
Yeah,
But
yeah.
yeah, that's great. Thanks so much, Adam.
Mhm. And
Well, and real quick, great
yeah,
talk. Again, it seems like just analyzing the connections between these nodes and stuff like that just helps with performance. And then also down the road, like if you're trying to edit, it just makes it a little bit clearer and more concise. Like just really big picture, I guess.
yeah.
Thinking about that, like when you're structuring just your application and stuff like that, I guess.
Mm-hmm. Oh yeah, it's a lot easier when you break down where all the nodes are. For example, the high level, here's an action, here's an event, and you see like the circle of the traditional Redux, pipeline flow, but you don't actually show like, well, here's how that interacts with components, and here's where the decisions are in there. It becomes harder to reason about and really share with others in a way which is quick to get where the part should go. Like, where do I stick this? So yeah. Definitely found that as well. Like having more of those written out was helpful.
I am curious, Adam. Given that you said you work at Switchfly, how have you guys like put this information to use at your job, and really like has it allowed you to make better decisions in terms of what tools you guys choose?
Yes, and well, okay, so we just started an entirely greenfield application. We are rewriting from scratch, and we just finished a prototype of that. That's basically throwaway code a few days ago. And so now we are in the phase of making all these decisions and figuring stuff out right now. And so like if from the perspective of like, how is this impacting our decisions? Yes. Like, have we used any of this stuff yet? Well, I am prototyping with them. I'm doing some experiments, and like, yeah, that's one of the reasons we're hiring for architects and senior level positions, is love to have people with more experience with some of these tools. And yeah, like we get to create together, which is one of the cool parts. I can say that one thing I did do was I created let me see if I can jump out of this here. Oops, let me go back one slide. And so one of the other things I created was the ability to query a Redux store using GraphQL. And so it was a library that just allows you to create a schema, and you add your initial state, and then you can do queries on any part of that schema, and it will denormalize it for you, and you can do queries and mutations using the same syntax. And so that was a learning project over the last year, which was digging into the GraphQL spec, digging into like, what are all the shapes of the things we're dealing with? What are all the coupling things that are coupled together? So I can toss that as an example in the chat. Here is, I think this is the link for it. Yeah, okay. So that's so this is the library, and there's a CodePen example, if anybody wants to play with that. So that was just like an experiment in how do we do how do you actually make it so you can use a GraphQL query on a Redux store without having to have a GraphQL backend. And so that is one tool which I sort of created for myself to see what was possible in like minimizing the amount of minimizing the number of edges for using GraphQL with Redux. Back when I realized, that was back before I realized that we would likely be transitioning to multiple pipelines through this analysis. So sort of an earlier experiment with that. So I suspect that we will have something related to that, or I would like to get something related to that would start moving us towards that type of multiple pipeline implementation. We'll be working with data visualization. So the performance considerations of straight GraphQL clients as is are not ideal. And so we will likely be implementing something. What that's going to look like, I don't know. But if we have a multiple pipeline implementation, it's entirely possible we could wrap something like Urkel in one pipeline and then have a second pipeline that is more direct for data visualization and animations.
Very nice. Cool. I do see that there's a question here in the chat. Elsa Nusi asks, what do you think the next step after React hooks would be that would make the code simpler?
Good question. Uh, I don't have a great example of this written right now, but I do think that the, do I? Let me check here and just, so that is something I've been asking as well, and it's how do you compose components better? And compose components without the edges of a, okay, so let's look at this one. So in this example, here we have, instead of, so let's say that this is a hook, or this is something which takes the output of a hook and applies it to the data property. And then you have something which says, okay, well, given the data property in these states, it has, it returns these three components. And so that limits your ability, so it creates more of a single responsibility principle concept where you can, one, you don't have to go as deep into functions. So you don't have all the edges that you would have if you are going into a function. Then you have the control flow edges of all of the you know, if loading, if error, of all these things in your function itself, and you can compose them directly. And so this is just the flow function from Lodash. And this exists in a number of other libraries. It's also sometimes called pipe. But yeah, so I think composability like this, allowing us to be able to compose our hooks into something that can be then composed again with other sets of hooks, is both shallower and simpler, but it takes some thought on how you would design this API. And I really don't have a great answer to that. That's something I'm sort of thinking through slowly, and we'll get to in the next probably couple of weeks. And yeah, so the ability to compose these things would help a lot, and that shallower and simpler would help us move faster with less sort of visual noise and better simple responsibility for faster change. Does that answer your question?
Yeah, that answers. I have another question. Are there like ways to use hooks that are well known, like conventions? And does having these kinds of conventions make the code more maintainable?
Well, actually, let me throw that question out. Does anybody else want to answer that? Like, I feel like I have used hooks somewhat, and well, yeah, quite a lot. However, I suspect there are others who have more experience with conventions on them than I do. We've been using Ember for the last year, and so I feel a little bit out of touch. So I used React before that, but it's sort of coming back to it at this point. And so if there are others who have experience with current conventions, curious how you would answer that question.
Yeah, the thing that comes to mind for me is composing hooks. So trying to break down, keeping hooks broken down into small pieces, but when there's common combinations, composing them and making those reusable, that's the first thing that comes to mind with specific to hooks. Same as we do with components. I don't even remember if it's something that React exposes directly or if some utility does that though. I've just done it with something.
Do you mean like custom hooks?
Yeah, and I'm thinking of custom hooks. I mean, granted, you can compose hooks with native hooks and custom hooks as well. I'll try to think of an example. I'm a little fried right now.
Thank you. Yeah, I think that having hooks within a function like that as they are, where you have to call them in order and they are in the function body, makes them more challenging. But you can just essentially you can, if you put them in an array like this flow here, that also runs them in order, so you can compose them together that way. it basically, the signature basically comes down to all you need is something that takes props. So if this is your props, and then you just return another object, which is, props plus, I don't know, styles. And then, so this can be a style component just like that with, 100. So that is all the signature you need to be able to compose to modify your props. And so if you put a use state in this, you can then create stateful styles or whatever. So as long as you return an object that has your props, and you can compose as many of those as you want together in a function.
Okay, does Ember have hooks?
Probably. We are currently trying. So this platform rewrite that we are doing is the current Ember version that we're using is like 1.7 or something. It's like, it's state of the art 2014. So, or 2013, that was long before the concept of hooks was out there. So the version that we don't have, the version that we have right now does not. The current version, there's probably an extension or something for it that does, but I don't know for sure.
Cool. Well, thanks so much, Adam. Once
Yeah.
again, I think we got most of the questions answered that came through the chat. So
Awesome.
really appreciate your time. I'm actually going to end the recording here. That was